Okay, so it's a yearby class, so we need to have some English lecture. Okay. So let's just from very beginning. So the notation is X means a life. A life. Life means an individual. Someone, okay, people. Age. His or her age is X. And so X must be greater or equal to 0 for T of X, T sub X. You can think of a lifetime of an individual X. And this is it's a continuous, should be this one, a continuous random variable. Random variable. And T sub 0, you can think of a lifetime of this. This is the individual with age 0. H is, it means i.e. lifetime of an individual at first. Meaning it's a lifetime of a newborn. Just a baby, a newborn baby. So what's X plus dx? What's this X plus 1? And this is what? What does this stand for? Actually means the age at death for this individual. So meaning it's X, right? Well, yes, but people die. And there'll be T sub X. Okay, let's see talk about some more about the T of X. Okay. Let's see. Suppose Tx follow a distribution of f. Let's say so f of x. Okay. I'll use the little x here to be consistent. Xt. Okay. This is equal to defined by probability of T sub x. That's equal to T. So it's equal to probability of this individual does not survive beyond x plus t. Okay, beyond the age of x plus t. And survival function s of xt is equal to 1 minus f of xt is equal to probability of tx greater than t. The assumption given in this in Dixon's book is the assumption be given that individual survives to age x, we assume, okay, so we need to add this the precondition. Given that, then we assume what? We assume these two are equivalent. Tx says these two events are equivalent. Okay. So given the individual survive to age x, then these two events are equivalent. We assume that. So the survival time for the individual x is this equal to t is equal to a newborn. The lifetime of newborn, let's say equal to x plus t. I.e., so meaning we assume probability of tx, let's say equal to t is equal to probability of t sub 0, let's say equal to x plus t, given that t sub 0 greater than 0x. To prove that in order to prove this, right, this inequality, actually it suffices to prove that t0 greater than x plus t is equal to p0 and probability of t0 greater than x, and that multiplied probability of t sub x greater than t, right? I just write this one function is a probability. So to prove this is sufficient to prove this inequality. And let's look at this. Oops.
9 minutes.
I made it 6 left. So for this one, right? This is actually equal to what? Probability of that's the this equality, your first first line of equality here. Basically, it's just the I think the probability of intersection A intersect B equals probability of A multiplied by probability of B given A. That's A given A, that's given B, right? So I can write this probability as t equal to x plus t equal to probability of t sub 0 greater than t multiplied by probability of t0 greater than x plus t given t0 plus x, t0 greater than x. And what's this? This just the here. So that's the x, let's say t of x greater than t. Okay. So this equal to that, so it equal to so we finish the proof. Okay. So to show this, basically just need to convert equality to the probability. Okay, just rewrite it as the probability and use this the probability intersection equal to, it's just the multiplication rule for the conditional probabilities. So you'll get this. Okay, and from this, actually we will obtain, actually prove this, but later on, basically, we really want to how we usually write this s of xt equal to s of 0x. So s of x of t is equal to the ratio of just the s of 0 x plus t divided by s of 0x. So we prove this, however, later on we use this formula a lot, right? So that's the equation for mixed sheet. That's why this is true based on this equality. After Mr. Johnson prove this equality, then you can rewrite it as this one, this one. Use it a lot. Okay? And if we so we can imply what? If we write the other way, the other side. Can you erase this part? Okay? I can erase this part. Okay, there we say the so I can imply that 1 minus sxt equal to 1 minus s0x plus t s0x. Okay? And what's this? This is the t of x greater than t. So this would be t of x, that's equal to t. And what's this? this is equal to f of xt. Okay? And this will be equal to s0x minus s0x plus t s0x. Okay? So imply that this is equal to s0x minus s0x plus t x0x. Okay? And I can do some more treatment here for the numerator. So this will be equal to 1 minus s0 x plus t and minus 1 minus s0 x. So I can rewrite it as what? That's f of 0 x plus t minus f 0 of x. One minus f 0 x. Something like that. Okay. But basically you can use any one. Each one is good. How much what we have done today? So far, not today. But chapter 2. Force of appeal. I'm starting with the Hazel ray. Okay. The Hazel function in the survival analysis. Lambda of x is lambda of x is defined as lambda of x is equal to T is a survival claim. That's the formal definition in survival analysis. That define Hazel ray, Hazel function. And actually it's just the same definition for force of mortality. It just let's be examine the mu of x. Mu x is defined as defines limit that the mu of x approach to 0 n the delta x. In the denominator that we have a t. We have what? We have a t sub 0 that's equal to x plus delta x. And given t sub 0 greater than equal to x. Okay. So you can see that here. Let's see T is survival type, but here the T0 is a survival type for newborn, right? And T0 is the survival type these two the same? No? Yes? My question here is just that's in survival analysis, right? That's formal definition defined for Hazel rate. But here, actually, the force of materiality actually just the Hazel rate. But it seems a little bit different here, right? This, we have x is equal to t, but here's missing. Are these two the same? Are these two definitions, these two functions the same? If I just replace t of t by t0, are they the same? Yes? No? No opinion. What do you think? Are these two the same? If I replace t0 by t, are these two the same? Yes? Yes? No?
Yes.
Yes. Why?
Why?
Well, actually, this is very simple question. What's this? What's this? This is equal to probability of t equal to x. And on top is x less than t less than the x plus delta x. And here we also have and at t equal to x. But I already have this one, right? I have this part, so this and I can just because it's already here. However, for this one, let's look at that. It's a little bit here. And I can write this part as this one as x less than t0 less than equal to x plus delta x. So again, we come back to your question. I have here same question. So as long as you can solve this, your question these two will be equivalent. But anyway, and that's your homework. But basically, I just want to point out that Hazel function and survival. The Hazel function in survival analysis is exactly the same. It's the same definition as motility. The same thing, but we use different name. Just in different field. Sometimes it will call the same thing in different name. Okay.
今天小考文章题我。真的。
Let's see what we have here. Okay. And we talk about T0, Tx. And again, this is the life individual h x. X must be non-negative. And we define a t sub 0, just the survival time for newborn. And that's the survival time for the individual x or lifetime. I used to use the survival time because the is well as this one. That's the terminology there. However, here we use lifetime, but the same thing. Okay. And what's x plus? What's this? What's this? X plus capital T sub x. Assembly. What's this? What's this? X plus T sub x. What's the number? What does that mean? Actually, it's the random variable. What does it refer to? What? What? It's what? Say again. Right, the age and death for this. So it's a random variable. And of the age and death for the individual x. It is a random variable, so it's follow okay. Follow say there's a CDF for that. So probability Tx is equal to T. So it's equal to the probability that the individual x does not survive beyond the age x plus t. Okay? So this t of x is a lifetime for x, and that's equal to t. So it means the individual does not survive beyond the age of x plus t. And remember, if this is fixed, if this is equal to t, right, and x plus t would be age of death for the individual. Okay. So let's see the definition here. Now remember, we assume the assumption that here is these two is equal to this the condition with property. That's assumption